Good afternoon, sir.
Good afternoon, everybody.
Good.
Am I audible to everybody?
Yes, sir.
Response in this poll. I have launched a poll. Just respond to this. As soon I capture your response ना उसके बाद क्लास शुरू करेंगे. जल्दी जल्दी दो. अरे मैंने कैमरा टर्न ऑन नहीं किया हुआ है, ठीक है? तो पहले वाले आंसर चाहे ना भी दो, बट इफ आई एम ऑडिबल ये जरूर आंसर दो, ठीक है? ऑडिबिलिटी के बारे में आंसर दो, विजिबिलिटी के बारे में. स्क्रीन विजिबल है नहीं वो बताओ बस, ठीक है? स्क्रीन तो विजिबल है ना? इज द स्क्रीन विजिबल टू ऑल? या अनम्यूट करो यार, जब तक मैं ना कहूँ ना अनम्यूट म्यूट मत खोलना अपना. जो भी है ना, जिसने भी अनम्यूट किया हुआ है, म्यूट योरसेल्फ. जल्दी जल्दी रेस्पॉन्स करो. अभी तक ये दो क्वेश्चन ही पूछे हैं, बताओ इसी में भी रेस्पॉन्स नहीं आ रहा आपको. अब वो मैंने कैमरा ऑफ किया हुआ है, कनेक्टिविटी इशू है, इस वजह से कैमरा ऑफ किया हुआ है. Quickly response in the poll. 26 student had participated. 10 student remaining. चलो तो फिर आज की क्लास शुरू करते हैं. So previous class में what we have did in motion in straight line. Motion in straight line. Straight line. इसी का ही एडवांसमेंट है ये चैप्टर, मोशन इन स्ट्रेट, मोशन इन प्लेन. ठीक है, जस्ट गिव मी अ सेकंड. ठीक है, तो today's topic is motion in plane. Good evening, JNV, and a very good evening to all of you. I welcome you in this class of Enable program. Today we are going to discuss about motion in plane. Got it? So everybody, have you revised the previous chapter, the motion in straight line? Motion in straight line का रिवीजन किस किसने किया भाई बताओ? Who have revised? This is motion in plane. Okay. इसमें सबसे पहले वी विल स्टडी अबाउट द रिजोल्यूशन ऑफ वेक्टर. ठीक है, आप में से कुछ लोग ऐसे होंगे जिन्हें अभी रेजोल्यूशन नहीं आता होगा करना, और जिन्हें आता है इट्स वेल एंड गुड. नाउ वी विल अंडरस्टैंड व्हाई वी आर रिजॉल्विंग द वेक्टर. टू गेट द इफेक्ट ऑफ अ वेक्टर इन ईच एंड एवरी डायरेक्शन, वी रिजोल्व द वेक्टर. वी resolve the vector into 2 or 3 components. Here if you see this vector A is given, okay, and the angle that it makes from x-axis is theta d. Now if I want to resolve this vector along x-axis and y-axis, so what I will do, I will assume that this length is particularly ay and the length along x-axis is ax. So in this triangle, let's say OAB, in triangle OAB, if you apply cos theta, so what should be the answer? Base upon hypotenuse. Base is OB and hypotenuse is OA. OAB is nothing but the magnitude of vector A, which is simply A. And what is OB? OB is AX. Because these two lines are parallel. This line and this line are parallel to each other. So this OB will become AX and OA is A. So from here we can get the value that AX is nothing but A cos of theta. Now, what about this vertical component AY? So for that, again, apply sin theta in this triangle OAB. So what it should be? AY perpendicular upon hypotenuse. And again, A is equals to what? A sin theta. This is the magnitude, okay, in each and every direction. In x-axis, the magnitude of this vector is A sin theta, and in y-axis, along y-axis, the magnitude of this angle is A sin theta, and along x-axis is A cos theta. Now, if I want to represent this vector in resolution form, what should I do? It should be AX I cap plus AY j cap. This I cap and j cap are what? The unit vectors along x-axis and y-axis. Okay. Now, you can put the value. You can put the value of this AX and AY in this expression, and what you will get? A cos theta I cap plus A sin theta j cap. Okay. So this is how we are going to resolve a particular vector. You must understand if from which axis the angle is given to you. If angle is given from horizontal, so always remember, if angle is given from horizontal, the x component always be A cos theta. And if angle is given from vertical, suppose ऐसे angle given है, ये angle given है theta. So this angle will become 90 minus theta. तो यहां से अगर x axis का component देखोगे ना, तो it will change. Now A sin theta will be the component in x axis. ठीक है, ऐसे ये देखो. Suppose this is the angle and ये मेरे पास theta है. Always remember, जिस साइड से आपने एंगल मेजर किया है ना, उस डायरेक्शन में जो कंपोनेंट होगा वो हमेशा A cos थीटा होगा, और उसके ऑपोजिट डायरेक्शन में जो कंपोनेंट होगा A sin थीटा. क्लियर है ये बात सभी को? यस एंड नो? इन द चैट बॉक्स गिव योर रेस्पॉन्स. डू यू अंडरस्टैंड द रेजोल्यूशन ऑफ वेक्टर नाउ? Now, based on the resolution of vector, we have this question for you. Okay. So the question is given as a force of 20 Newton acts on a particle along a direction, making an angle 60 degree with the horizontal. The component of the force along the vertical direction will be. Okay. Everyone has to respond. Otherwise, I will not. Yeah. Okay. Everyone has to respond. Give your response about this. Have you understood the resolution of vector? Each and every participant. There are 41 participants in there. Each of one you have to respond. Okay. Now, try to solve this question. So, according to this question, a force is given to you as vector, force vector. ठीक है. Force vector का magnitude कितना given है? 20 Newton given. ठीक है. And it is making an angle 60 degree with the horizontal. ये horizontal axis मान ली हमने x axis. This is vertical axis y axis. अब ये क्या बोल रहा है? The component of force along the vertical direction. और ये एंगल जो है ये वर्टिकल से मेजर हो रहा है. एंगल इज मेजर्ड फ्रॉम वर्टिकल. सो यहां से हमने ये एंगल मेजर किया. कितना? 60 डिग्री. नाउ टेल मी, आई हैव जस्ट टोल्ड यू, जिस साइड से, जिस एक्सिस से आप एंगल मेजर करते हो, दैट कंपोनेंट विल बी एफ कोस थीटा, यानी कि एफ कोस 60. थीटा इज 60 and the magnitude of f is also given to you as 20 Newton. So it will become 20 into cos 60. Cos 60 will be 1 by 2, which is 10 Newton. Very good. So option 3 is the correct answer. Now tell me, what is the horizontal component of this? What is the value of fx? Tell me rapidly in the chat box. Rapidly told me the value of x component. Will it be same or different? Everyone. Abhishek is saying 10 root 3. JNV Bhavnagar is also saying 10 root 3. Okay. Let's see if it is 10 root 3 or not. Fx is f sine 60. F is given as 20 Newton. Sine 60 is what? Root 3 by 2. So this will cancel out, gives you 10 root 3 Newton. Or you can say that 17.32 Newton, because the value of root 3 is 1.73. Okay. Clear है? Very good, JNV Warangal. Acer Bhavnagar. Acer, could you please tell me your name? The guys have name, showing name as Acer. Okay, those who are putting their cell phone unmute, please mute yourself. Okay. Now we will move to the motion in plane. That is the topic of today. Okay. Now if you will see here, this person is throwing a ball over a stone, and the path of the stone is slightly changing. Okay. Rather than being in a straight line motion, it is being in a curved motion. Okay. So why it is happening? So that is why we study about this motion in plane. So what exactly the motion in plane is? When we talk about the two dimensions, when two dimensions are involved in any kind of motion, when two dimension, I'm repeating this self, when two dimensions are involved in a motion, that particular motion is termed as motion in plane. Because by involving two dimension, you will make a plane. And anything that is moving in a plane, anything that is moving in a plane involving two dimension or two axis of motion. Okay. So here, generally we would consider x-axis and y-axis as the axis of motion. So that is why this particular motion is called as motion in plane. Okay. Clear? The path that is being taken by this particular object, which is named as projectile, the object that you are throwing in the air or space with an oblique angle. Oblique angle means the angle is not vertical. Okay? The angle is not 90 degree. You are throwing it at some angle which is less than 90 degree. That particular object is termed as what? Projectile. Okay? And the path of the projectile is termed as trajectory. ठीक है? इस पर्टिकुलर पैथ को हम क्या बोलते हैं? ट्रेजेक्ट्री. या आईफोन 16 प्रो मैक्स. व्हाट इज योर डाउट? टेल मी योर डाउट. बताओ क्या डाउट है आप. तो मोशन इन प्लेन सबको समझ में आया. व्हाट इज मोशन इन प्लेन? व्हेनेवर द टू एक्सिस ऑफ मोशन आर इन्वॉल्व. ठीक है? जब भी मोशन में दो एक्सिस इन्वॉल्व होंगी, एक्स या वाई, वाई या जेड, जेड और एक्स, whatever the combination of the axis, but the number of axis will be 2 or 2 dimension will be considered in that motion is termed as the motion in plane. ठीक है? Yeah, I will discuss it. This is in the very good question, but we will discuss it in the next slide. So here I have shown you some curve which is involved in two dimensions. X and Y axis के बीच में we have involved two curve. These R1 vector and R2 vector represents the position of these two places, let's say A and B. Okay? So you can see here that R1 vector is given by combination of x-axis plus combination of y-axis. So in this position vector, you can easily see that there are two axes involved in this motion. So that is why this motion is termed as motion in plane. Now, you can see this animation view. In this motion, this ball involving height also and range also. That this ball is covering the distance in both direction, vertical direction and horizontal direction. So that is why it involves two dimensions. Okay. Now, yeah. So similar concept from this motion in plane is that we would like to study here is projectile motion. So in this, you have to understand some terms, that what is projectile, why it is called as projectile, all of this stuff you have to study. Okay. So in projectile motion, you can study this definition that is being displayed. A projectile is any object thrown into space upon which only force is acting, that is gravity. तो जब भी आप किसी ऑब्जेक्ट को स्पेस में फेंकते हो, स्पेस मींस जहां भी आप खड़े हो वहां से आप टूवर्ड द स्पेस. ठीक है? विदाउट throwing it vertically, you are throwing it at some angle. So that particular object is termed as projectile, and the forces under which this projectile is being thrown is termed as gravitational forces. Okay? You can see in this trajectory, this projectile is being thrown and only the gravitational forces of acceleration is acting here. Okay? इसके अलावा you can say that air resistance is also here. Air resistance is also here. But we are not considering air resistance. ठीक है, air resistance is very minimal, but yet we are not considering air resistance. So in the absence of, the right definition to it will be, in the absence of air resistance, when in the absence of air resistance, ठीक है, when only the gravitational force is acting, in that case that particular motion is termed as projectile, and whatever the object that you are throwing into space is termed as projectile itself. ठीक है, तो projectile किसे बोलेंगे? That object that you are being thrown at some oblique angle, less than 90 degree. ठीक है, clear है? Tell me yes and no about this projectile motion if it's clear to you. Okay, so the force that is being acting is gravity. That particular object is termed as projectile, and that particular curved motion or the curved path is called the projectile motion. Okay, the path followed by the projectile is known as the trajectory. ठीक है, so this path को हम क्या बोलेंगे? itself trajectory. Clear? Now equation of motion in plane. So जैसे हमने स्ट्रेट लाइन मोशन में पढ़ी थी, इक्वेशन ऑफ मोशन इन वन डायमेंशन, v is equals to u plus at, v square is equals to u square plus 2as, and u s is equals to ut plus 1 by 2at square. These same equation you can apply here, because gravity is somehow treated as constant force. ठीक है, in this projectile motion we treat gravity as a constant force. So you can apply the equation in same manner, that Vx, but for both the axes you have to calculate it differently. ठीक है, either you are calculating the velocity, you have to calculate both the velocity in x direction, velocity in y direction, displacement in x, displacement in y, and the final velocity in x, final velocity in y. ठीक है, yes 45 एंगल पर ही जाएगा मैक्सिमम. ओके, चलो नेक्स्ट पे बात करते हैं. अब अभी ये कुछ एनालिसिस है प्रोजेक्टाइल मोशन से रिलेटेड. ठीक है, आई थिंक ये मोशन सभी ने किया होगा. जब भी आप कोई बॉल थ्रो करते हो, कोई भी ऑब्जेक्ट आप थ्रो करते हैं, तो दैट मोशन somehow have experienced by you all. ठीक है ना? What is the equation of this trajectory? So the equation of this trajectory is y is equals to x tan theta minus gx square over 2u square cos square theta. This is a very heavy equation, but you have to remember it. Okay, and it's very easy to remember. It's x tan theta simply minus gx square. Now you just have to 2 times of u cos theta का whole square. ठीक है, क्लियर है? ये जो पैथ है, ये जो ट्रेजेक्ट्री है, इस ट्रेजेक्ट्री को हम क्या बोलते हैं? पैराबोला. जिस शेप में ये आ रही है ना ट्रेजेक्ट्री, व्हाट इज द शेप ऑफ दिस पैथ और शेप ऑफ दिस ट्रेजेक्ट्री? दैट इज टर्म्ड एज पैराबोला. लेकिन देयर इज अ कंडीशन हियर कि ये पैराबोला कब होता है? ठीक है, ये पैराबोला किस सिचुएशन में रहेगा? दैट यू हैव टू अंडरस्टैंड. व्हेन देयर इज एन एयर रेसिस्टेंस प्रेजेंट, if air resistance is there, then no parabola. ठीक है, उस सिचुएशन में ये जो पैथ होगा ये पैराबोला नहीं होगा. ठीक है, देयर इज सम अदर ट्रेजेक्टरी, अदर ज्योमेट्री आल्सो, बट दिस इज नॉट पैराबोला इन दैट केस. यू रिमेंबर दैट पॉइंट. नाउ व्हाट इज द रेंज ऑफ प्रोजेक्टाइल? Range of projectile is that phenomena when you throw the projectile and up to which maximum distance on x-axis, the maximum horizontal distance that it cover. I'll write it here. Maximum horizontal horizontal distance. So maximum horizontal distance is the range of projectile. ठीक है? It is given by u square sine 2 theta by g. There is another formula also. You can term it as 2 times of ux, the x component of velocity, multiply by uy, y component of the velocity divided by g. In this format also you can remember it. Similar way में what is maximum height? The maximum height attained during the projectile motion by a projectile is termed as maximum height. अब मैक्सिमम हाइट को एक तरीके से और याद कर सकते हो, it's u sin theta. You can write it as u sin theta by 2g whole square. U sin theta is the vertical component of velocity, uy square by 2. इस फॉर्मूला से भी इसे याद रख सकते हो. The next formula is time of flight, the time taken by the projectile during the entire motion, complete motion. तो यहाँ स्टार्टिंग पॉइंट से एंड पॉइंट तक जितना भी टाइम लिया प्रोजेक्टाइल ने, दैट इज द टाइम ऑफ फ्लाइट, एंड इट इज गिवन बाय 2u sin थीटा बाय g. तो अगेन टाइम को भी आप ऐसे लिख सकते हो 2uy बाय. क्लियर? नाउ just hit the answer of this question. The trajectory of projectile is, everyone answer in the chat box. Option A, option B, option C, option D. Option C you are saying. No, I have told you already. Look, this is the equation of parabola. But when there is an air resistance, so addition to this gravitational force, we would have some air resistance also. If there is some air resistance. So in the presence of air resistance, the path of projectile is not parabola. Okay? There is something other path, but it is not parabola. So the trajectory of a projectile is not always parabola, but we can say that in the absence of air resistance, it would be a parabola. Okay? Is it clear to everybody? Very good, JNV Bhavnagar, JNV Kurnool. Okay, guys. Now, we will be only solving questions right now. So here's some important concept for you. This is the maximum height of the projectile. Okay, and this is the range. This is particularly called as range, R. And if this angle is theta, so this is a very famous question that at which angle the range would be maximum. So always remember at theta is equals to 45, the range is maximum and given by u square by g. If R is maximum, then in terms of maximum height is 4 times quadruple of the maximum height. This relation you can always remember. The ratio of range to the height is 4 by 10. Okay? So you can verify this statement also when theta is 45. So R by H is what? 4 by 10 45. Or 10 45 is 1. So R is equals to 4 times of. ठीक है? यहां से आप इसे भी याद कर सकते. ठीक है? Now move to the questions. This is the very first question here. Two objects are projected, at an angle theta degree and 90 minus theta to the horizontal with the same speed. The ratio of their maximum vertical heights. Speed उनकी same है. थीटा एक बार थीटा डिग्री से थ्रो किया है, एक बार 90 माइनस थीटा से. Suppose this is theta and again the angle is 90 minus theta. दोनों टाइम्स में वेलोसिटी सेम है. दिस इज वाई एक्सिस, दिस इज एक्स एक्सिस. टेल मी द रेशियो ऑफ मैक्सिमम वर्टिकल हाइट. अभी मैंने बताया था फॉर्मूला, एच इज व्हाट, यू स्क्वायर साइन स्क्वायर थीटा बाई 2g. ये फॉर्मूला है. ठीक है, एक बार थीटा पुट करो, एक बार 90 माइनस थीटा, h1 और h2 करके रेशियो निकालो. टेल मी द आंसर. So h1, we can write h1 as what, u square sin square theta itself, because first angle of throw is theta, so it is 2g. Equation 1. h2 is what, u square sin square 90 minus theta divided by. Now sin 90 minus theta is what, cos theta, so we can write it as u square cos square theta by 2. ठीक है, take the ratio h1 by h2. So this u square and 2g will cancel out. Only the thing remaining here is sin square theta divided by cos square theta. So h1 by h2 will become tan square theta by 1. So the ratio here is tan square theta into. ठीक है, ऑप्शन सी इज द करेक्ट आंसर. ओके, वेरी गुड जेएनवी भावनगर. Guys, put yourself on mute. Okay, let's just move on to the next question. For a projectile motion, the angle between the velocity and acceleration is minimum and acute at only 1 point, 2 point, 3 point or 4 point. बताओ, ए बी सी डी की टर्म्स में आंसर करो. ठीक है, ये अपना प्रोजेक्टाइल मोशन है. ठीक है, लेट मी चेंज द कलर. ये वेलोसिटी है और ये हमारा एक्सेलरेशन, ग्रेविटी एक्सेलरेशन. ऑप्शन बी 2 पॉइंट. ओके, लेट्स जस्ट सी. सो फ्रॉम हियर टू द मैक्सिमम पॉइंट, यहां से मैक्सिमम पॉइंट तक, if you just see, this is the velocity and this is angle. So obviously this is not acute, this is obtuse. Obtuse angle है. इसका मतलब यहां से यहां तक तो there is no possibility. But when it hit the maximum height, only horizontal component of the velocity is remaining. ठीक है. So at maximum height you can say the velocity का only horizontal component is there and gravity is there. The angle between them is 90 degree. If you talk about the later angles, इसके बाद this and this is the velocity and this is gravity. ठीक है, so after the maximum point the angle would be like this. ठीक है, so we can say that only at one point at the maximum height the angle would be 90 degree, which is acute angle. ठीक है, got it? क्योंकि इसके बाद क्या होगा ना, यू कैन से दैट कि यहाँ भी तो एंगल एक्यूट है, नहीं, यहां तक जो वेलोसिटी है वो फिर से बढ़ना शुरू कर देगी, इसलिए इनके बीच का एंगल जो है ना बढ़ जाएगा। वेलोसिटी की मिनिमम वैल्यू भी कहाँ पे होगी? एट मैक्सिमम हाइट। सो एट दैट पर्टिकुलर पॉइंट ओनली विल गेट अ एक्यूट एंगल, ठीक है, नॉट आफ्टर दैट, नॉट बिफोर दैट। क्लियर है? वेरी गुड। सो एट ओनली वन पॉइंट, वो भी कहाँ पे? मैक्सिमम हाइट, यू विल गेट अ एक्यूट एंगल। ठीक है, चलो ये वाला क्वेश्चन करके दिखाओ। गिविंग यू 1 minute to solve this question. You have to find the maximum range of gun on horizontal plane, which is given to you as 16 kilometer. 16 kilometer is the range given to you. Acceleration of gravity is given to you. Then you have to find out the muzzle velocity. ठीक है, the velocity at which the bullet coming out, you have to find out that. ठीक है, JNV Kalaburgi is saying A. Let's just see that. So first of all, range is given to you. R is equals to U square sin 2 theta by G. ठीक है, and range is given to you 16,000 meter, because gravitational acceleration is 10 meter per second square is given to you. So you need to convert this range also in meter. So it is 16,000 meter. U square sin 2 theta divided by G. Now this G is also given to you. Clear? U square sin 2 theta 16,000 into G. Option C you are saying. ठीक है, अब देखो यहाँ पे what the mistake student do, they will apply this formula. In respect to that, if you just read the first line of the question, na, it is maximum range. And when will I get the maximum range? Maximum range is 4 times of the horizontal, maximum height, and we will get this maximum range at 45 degrees. So it's very simple. You just have to apply this formula. You do not need to involve the angle in that. Okay. So here we can say that the muzzle velocity is muzzle velocity को कैसे रिप्रेजेंट करेंगे? R max equals to U square by G. R max is 16,000 into 10 also from this gravitational acceleration U square. So U will be 400 meter per second. Option C is the correct. Very good, guys. All of you have answered C. Most of you have answered C. So I hope you got the concept here. Now just try to solve this question. I'm giving you 1 minute to solve this question. In this, a constant acceleration is given to you, 8 I cap plus 2 J. ठीक है, the particle starts from origin at t is equals to 0 with a velocity of 10 J cap. Velocity, initial velocity is also given to you as 10 J cap, and move in the xy plane with a constant acceleration of 8 I cap plus 2 J cap. At an instant when the x coordinate of the particle is 16 meter, y coordinate of the particle is. So you have to find out the coordinates. Okay. Basically, it is asking for what? Trajectory of this. Like AX is given to you as 8 meter per second square. AY is also given to you as 2 meter per second square. UX initially 0. UY is what? 10 meter per second. Because initially the velocity is in vertical direction only. ठीक है, y direction में सिर्फ है velocity. Now, at an instant when x coordinate of the particle is 16 meter, so at that particular moment you have to find out the time. कि किस टाइम पे 16 मीटर को ये क्रॉस कर लेगा. तो उसके लिए वी कैन अप्लाई द इक्वेशन vx इज इक्वल टू ux प्लस ax इंटू टी. ठीक है, vx is ux is 0, ax is what? 8 into time we have to find out. So this is equation 1 we get. Secondly, what we can do? The value is provided at x-axis. Sx is equals to ux into t plus 1 by 2 ax into t square. This formula we can apply. So ux initially is given as 0. So this will become 0. What is the value of sx then? 16 meter. 1 by 2 ax की value कितनी है? 8 into t square. This will become 4. 4 4 the 16. So t will become 2 seconds. So when time crosses the value 2 seconds, the particle is at 16 meter on x-axis. Okay, now very easy to find out sy. Sy is what? uy into t plus 1 by 2 ay into t square. अब देखो sy we have to find out. vy is given to you, initial velocity y direction में ही है 10 मल्टीप्लाई बाई कितने टाइम पे? 2 सेकंड पे निकालना, प्लस 1 by 2 ay कितना है? 2 into 2 square. This and this will cancel out. This will become 10 into 2 will 20 plus 2 square is 4. So it is coming out as 24 meter. Option D is the correct answer. बताओ किस किस की समझ में नहीं आया, जल्दी से कमेंट करो. Yeah, very good, Purnul. D is the answer. Everybody clear with this? Give me a yes or no in the chat box, or you can raise the hand, whatever you want. Now this question, this is a little tricky question. Everybody understand the previous one, na? Let me just re-explain it again. देखो acceleration हमें given 8i cap 2i j cap. This is the x component, this is y component. ठीक है, ये x component है, ये y component है, दोनों की अलग अलग वैल्यू हमने लिखी. अब 16 मीटर x डायरेक्शन में डिस्टेंस कवर्ड है, वहां के लिए कितना टाइम लगेगा वो हमने निकाल लिया. कि 16 मीटर जाने में हाउ मच टाइम इट विल कंज्यूम, तो 2 सेकेंड. अब 2 सेकेंड हमारे पास टाइम भी है, ए वाई भी गिवन है, वी वाई भी गिवन है, तो एस वाई निकालना क्या होगा? वी वाई इज ऑल्सो गिवन, टाइम इज ऑल्सो गिवन, ए वाई इज ऑल्सो गिवन. सो वी हैव फाइंड आउट द वैल्यू ऑफ एस. ठीक है, नाउ this question, the trajectory of the projectile projected from origin is given by the equation y is equals to what? Y is equals to x minus 2x square upon 5. अब यहां से हमें बहुत सारे assumption लेके चलने पड़ेंगे. So we have to find out the initial velocity of the projectile, यानी कि u हमें find out. अभी मैंने कुछ देर पहले ही आपको एक इक्वेशन दिखाई थी, ये the equation of the trajectory y is equals to x tan theta minus gx square over 2u square cos square theta. सिंपल सी बात है, कुछ नहीं करना है इसमें, सिर्फ कंपैरिजन करना है. y is equals to x tan theta minus gx square u square cos square थीटा। ठीक है, अब देखो जो भी x के साथ मल्टीप्लाइड है वो किसकी वैल्यू है, टेन थीटा। सो हियर वी कैन से दैट टेन थीटा इज व्हाट, वन, which means theta is 45 डिग्री। तो दिस इज द केस ऑफ मैक्सिमम रेंज। इनिशियल वेलोसिटी कैसे फाइंड आउट करें, आर मैक्स इज नथिंग बट यू स्क्वायर बाई जी। ठीक है, अब देखो आर मैक्स की वैल्यू हमें गिवन तो है नहीं, उसके लिए क्या करेंगे, नेक्स्ट चीज इससे कंपैरिजन कर देंगे। सो जी इंटू एक्स स्क्वायर बाई यू स्क्वायर कॉस स्क्वायर थीटा, एक्स स्क्वायर के साथ जो मल्टीप्लाई है दिस इज द वैल्यू ऑफ जी अपॉन यू स्क्वायर कॉस स्क्वायर थीटा विच इज 2/5 and it is equals to g upon u square cos square. Now invert this, it will become u square cos square theta divided by g, which is equals to what, 5 by. Now theta is 45, theta is already calculated 45 degree. So cos 45 की वैल्यू कितनी होती है, 1 by root 2. It will become u square by 2 g equals to 5 by. ठीक है, अब देखिए यहां से आर मैक्स की वैल्यू भी आप 5/2 कह सकते हो। ठीक है ना, यू स्क्वायर 10/2, इट 2 and 2 विल कैंसिल आउट। ठीक है, यू स्क्वायर हियर विल बिकम 5 into 10। You can take the common and square root of it and then you will calculate। ठीक है, pretty simple ना। ठीक है, no worries if option doesn't match, no worries। क्लियर है सभी को ये आंसर। आर मैक्स की वैल्यू 5/2 होगी, यू स्क्वायर बाई जी हो गया। ठीक है, अब यहां से when you put the value of g as 10, 2 5 are 10, so you will come out as 5 मीटर पर सेकेंड। ठीक है, बस फर्स्ट कंडीशन क्या याद रखनी है, थीटा इज 45 डिग्री। क्लियर है, दिस वन। ये लास्ट क्वेश्चन है आज के सेशन का। A ball is projected from point A with velocity 20 meter per second at an angle 60 degree to the horizon. At the highest point B of the path, the velocity of the ball. Very simple. At the maximum point, only horizontal component of the velocity will remain. Only Vx you have to find out. And Vx does not depends on the gravitational acceleration. Okay? Because at every point, if you will see, the gravitational acceleration is at 90 degree with this. Okay? The gravitational acceleration is the acceleration in y direction. In due to the absence of acceleration in the x direction, the velocity in x direction will remain constant. क्या रहेगी, constant। So whatever be the initial component of velocity in x direction will be the final component of velocity in during the entire motion। ठीक है, complete motion में the same component will remain। ठीक है, so now you can say that देखो v is given to you as 20 meter per second, so vx is what, v cos of theta, v is 20, cos theta, theta is 60 degree, so it will become root 3 by, sorry, cos 60 is 1/2, so vx will become 10 मीटर पर सेकंड। ठीक है, क्लियर है, किसी को कोई डाउट है इसमें। Anyone, any kind of doubt? Yes and no? Any kind of doubt you can ask right now. Okay? This is the question for your homework. Try to do it. In the next class, we will discuss about it. So if anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive in the lecture and being responsive. Hope you have enjoyed the session. Now I'm launching a poll. Just give me the feedback of it. And then you can leave the lecture if you do not have any doubt. Thank you.